Students, I generally say that to understand a subject like physics, you have to try to solve the numericals from it. It's like life. To understand life, you have to solve the problems that come before you. So no wonder that people call numericals as problems also. So today we are going to try to solve some problems from our subject. So today we are going to solve some numericals from the physics part of science. Students, I have taken these numericals from the sample question papers of the last year and present year. So starting with first problem, when a 4-volt battery is connected across an unknown resistor, there is a current of 100 milliampere in the circuit. The value of the resistance of resistor is, so what we have to find here? We have to find resistance of a resistor. And what is given? The potential difference and current. So first step while solving any problem is to arrange the information that is already given. So they are given voltage of a battery, so that you have to write down voltage of a battery 4 volts. And second thing that they have given is current in the unknown resistance. That current is 100 milliampere. Then we have to think of the relation. So the only relation that we can use here is the Ohm's law. Okay, because this relation connects potential difference, current and resistance. So obviously if we want to find resistance, we will use Ohm's law. The next thing that you have to think about is, before replacing or substituting these values in the formula, are they in the same system of units? In this case, the answer is no, because this is in SI system, but this is not in SI system. Current is in milliamperes, and SI unit for current is ampere and not milliampere. So we would have to convert this milliampere into ampere. Now, I is equal to, that is the current, is equal to 100 milliampere, and in ampere if you want to convert, then you have to divide it by 1000, because we all know that 1 ampere is 1000 milliampere. So how did I get 10 raised to minus 1 ampere? I divided 100 milliampere by 1000. So dividing 100 by 1000, I will get 1 upon 10 amperes. And 1 upon 10 is nothing but 10 raised to minus 1 ampere. So once you convert milliamperes to ampere, you have to know the Ohm's law, right? So Ohm's law, as you know, current flowing through the conductor is directly proportional to the voltage or potential difference across the ends of the terminal. So R is equal to V upon I, or you can say V is equal to I into R. Here R is constant, as you know. So R is equal to V upon I. So what we have to do is simply substitute. Instead of V, you have to put the potential difference, and instead of I, you have to put the current. So that's what I will do. R is equal to 4 divided by 10 raised to minus 1. Now this 10 raised to minus 1, once it goes to numerator, what will happen? It will become 10 raised to 1, as we know from the properties of indices. So R is equal to 40 ohms. So that's our answer. Well, that was first numerical. The second numerical is, it is desired to obtain an erect image of an object using concave mirror of focal length 12 centimeter. So we have been given, or we have been provided with the focal length of a concave mirror. What should be the range of the object distance in above case? We have to find the range of the object distance, right? Then second question is, will the image be smaller or larger than the object? That we have to think the nature of the image. And the third question is, where will the image of this object be if it is placed 24 centimeter in front of the mirror? Now, starting with the first part of the question, what should be the range of the object distance? If we already know the focal length, what should be the range of the object distance in above case? Our desire or what we want is the erect image. So remember that erect image comes with the virtual nature. So for concave mirror, that case is in concave mirror, erect is formed only when the object is placed between pole and the focus. So if you place it in less than 12 centimeter distance, it is going to give you an erect image. Then the B part of the question was, what was the B part? Let us see again. Will the image be smaller or larger? And draw the ray diagram to show the formation of the image in this case. So in such cases, generally the image is enlarged. It is bigger than the object. So as you can see here, this is an object and this is an image. This is a virtual image because it is behind the mirror. And obviously it is larger. Then the C part is, what if the object is placed at 24 centimeter? Now remember that the focal length of the given concave mirror is 12 centimeter. So it is double that of focal length. So it is center of curvature. If the object distance is 24 centimeter, which is the approx position of center of curvature, then the image will be formed obviously at center of curvature only. So it will look like this. This is the object and this will be the image, because that's what happens. In case of concave mirror, if you place the object at center of curvature, then image also forms at center of curvature. So that was numerical number 2. Then numerical number 3 is, if the power of the lens is L1 and L2, they are in the ratio 4:1, power is given. What we have to find here? Ratio of the focal length. So power of the lens, you have to write down 4:1, and what we have to find? Ratio of focal length. Now as we all know, what is focus? The concept should be clear, that's why I have written it again. It is a point of intersection of all the reflected rays for which incident rays strike the mirror parallel to the principal axis. The distance from pole to focus is a focal length. Okay, and ratio of the powers is already known. So power of lens is 4x and power of lens L2 is 1x. Now we know that power is the reciprocal of the focal length. So focal length f L1 will be 1 upon 4x and focal length of L2 will be 1 upon x. Then we have to simply take the ratio of the two. So 1 upon 4x divided by 1 upon 1x will be 1:4. Okay, so it will be reciprocal of P1 raised to P2. Okay, P1 is to P2, not raised to, it is to P2. So the ratio of the powers was 4:1. So obviously the ratio of focal length will be 1:4, reciprocal of the power of the lenses. Then the last numerical for the day. Sumati did some preliminary experiment with the lenses and found out that the magnification of the eyepiece is 3. In her experiment with L2, she found an image at 24 centimeter. Magnification is 3. Image was at 24 centimeter. At what distance she put the object? So we have to find the object distance for her. Now magnification, as we all know, it is V upon U, image distance upon object distance. Magnification is given 3, image distance is also given 24 centimeter. So what we have to do here is very simple. You have to simply plug in the values of magnification and image distance and find out the object distance, that is U. So here in this case, it will be 3 is equal to 24 upon U, or you can write U is equal to 24 upon 3, which will give you 8 centimeters. So object distance is 8 centimeter in this case. Well students, that was all for today. I hope you understood the numericals that we tried to solve. If you have any doubt, feel free to ask. You can put your comments in comment box. So see you during next session with the new topic. Until then, take care. Bye bye.